Welcome to this lecture, where we will set the foundation on how and why we need reinforcement learning. At the heart of this AI technique lies the question how we can interact with an environment. Classical AI methods like search and optimization can plan to reach a goal, like stacking these cubes on top of each other. This requires a model of the environmental dynamics and yields a sequence of actions from the initial state to the goal. However, what happens when we send our little robot here into the wild? If we don't know the environment, or if we're not sure what the reactions to our actions will be, either because the environment contains humans or is simply stochastic. In these cases, we cannot plan the interaction. We need to learn it. So our goal is to apply the framework of machine learning to learn how to interact with an environment. And for this, we need to formalize the environment as a Markov decision process, or MDP. At the core of the MDP is the state space S that describes all possible configurations of the environment can be in. In the beginning, the environment is in state S0, which is drawn randomly from some distribution. Next, our agent AI can choose between actions from action space A. This action has two effects. First, the environment returns a reward, a single number that tells the agent how good this particular one action was. Second, the environment reacts to the action by transitioning into a new state that is drawn randomly from distribution P. After this, the agent chooses the next action, and so on. The challenge of reinforcement learning is to find actions for every state that do not only maximize the immediate reward, but also all future rewards the agent will encounter. This is a complex problem because actions change the environment and agents must consider where they will end up. And remember, the agent does not know where it will end up or which reward it will receive there. It has to experience this by trial and error. Let's look at an example. This is the mountain car environment, where we control this little car here in the top right. The state of the environment is the car's position and velocity, which we can change by selection of an action that accelerates either to the left or to the right. This changes the state in the next time step according to the simplified Newtonian physics. Here at the bottom right, we see the two-dimensional state space of cars' positions and velocities. Every point in this square is a possible state of the environment, and the colored curves show how the state evolves when the agent continuously chooses one of the three actions. The goal is to reach the top of the mountain, which returns a reward of 1, whereas all other states are not rewarded. However, the problem is that the car does not have enough power to get to the top of the mountain in one go. As we see here on the bottom left, the car needs to first pick up speed by moving back and forth. Now imagine you have to learn this without knowing anything about the environment, just by interacting with it. That's what reinforcement learning does. So in summary, sometimes an AI needs to learn how to interact with its environment. In this video, we have formalized the environment as an MDP, and we have familiarized ourselves with the mountain car environment. I hope you understand now the setup and the challenge of reinforcement learning.